Alright class, I might make this the last video. I'm debating if we're going to do the Melissa rocket ship problem in class or not, and I think we will. But right now we are talking about modeling with quadratic functions. This is important because we're going to be using all the things we've learned about quadratics and come up with different ways to actually come up with the equations now based on points given in the situation. There's a part on the test that's very important to know how to do this for the rest of the problem, so make sure that you understand how to come up with the different equations. So the first one is vertex form. You guys have seen vertex form. That's the form we get when we complete this square. We use this form when we are given a vertex, obviously, because if we are given a vertex we could throw it into vertex form. So when given a vertex and one other point. Okay, because what happens is the format for vertex form again is y is equal to some constant out front, x minus h, so the opposite of the x coordinate, squared, plus k, which is the y coordinate. Okay, the y value for the vertex. Okay, so the vertex would be h comma k. Alright, so let's do that. Write a quadratic function with vertex, so here's the vertex, 2, -3, and 0.41. First of all, let's plug it in with what we know. We know that we don't know a yet, and generally with these problems, that's what you're solving for. We need to know what that constant is to make this a correct quadratic. We're going to put x minus 2 quantity squared minus 3. So all I did was I put this in vertex form using my vertex. There's an opposite 2 there, and then the same sign for y. Okay, now we can use this point to actually find out what that a value is. I know that 4,1 is also on this equation, so I'm going to plug in 4,1. So I have 1 for y is equal to a times 4 minus 2 squared minus 3. Alright, let's solve this. 1 equals 4 minus 2 squared is 2 squared is 4a minus 3. I move the 3 over, I get 4a is equal to 4, which means that a has to be 1. So I found that a is 1, so my final equation is y is equal to, and you can either put the 1 here or you don't have to, you can just leave it as x minus 2 quantity squared and minus 3. And that is our equation in vertex form, based on the vertex and this given point. That's all you do for vertex form. Okay? So that's what vertex form is. Intercept form. Intercept form you could also think of as factored form. Okay, think of this as factored form. And you use it when you have the intercepts, have the x-intercepts. And a third point. Okay? And this form is, again, like factored form, we have y equals, there's some number out here, we don't know what that is yet, but it's x minus p, x minus q. Again, where your intercepts are x equals p and x equals q for your intercepts. Okay, again, this looks like it's factored, that's what you do. Write an equation in intercept form, so y equals a x, and then my intercepts are -2 and +3, so it's the opposite of that. This will be x plus 2, this will be x minus 3. Again, this is in factored form. The only thing we have to care about is this a value, and we're going to use our third point to find that. So my y value is 2, my a value we are looking for, we have -1 plus 2 and -1 minus 3. So we get 2 equals a times 1 times -4, and so this is -4a equals 2, so you should get a is equal to -1/2. Okay, so the final step though is to rewrite it as that form. So y equals -1/2 times the quantity x plus 2 and x minus 3. So we just came up with a quadratic in vertex form, in intercept form, using our intercepts and a third point. Now, if I asked you to put this in the standard form, you just multiply that all out. But we don't have to do that right now. But we will talk about standard form, because standard form is the I think it's the hardest one to set up, but it's actually the easiest one to calculate because you use your calculator for it. To use standard form, you do this when you have 3 points. On the graph. 3 points on the graph. That are not like the intercepts or vertex or anything. So these are just 3 generic points. Okay? And the form for standard form, which you guys should already understand because we have been dealing with it, is ax squared plus bx plus c, where a, b, and c are numbers. Okay? So, let's do the problem. So this is the standard form, and let's go down to the problem example 3. Write the equation in standard form with the points blank, blank, and blank. Well, basically what happens is we need to figure out what a, b, and c are. So we're going to be doing a 3x3 system here. Okay, so you take, I'll rewrite standard form up here just so we can look at it. And what happens is you take this first point and plug it in for y and x and come up with an equation. So this becomes a times negative 2 squared plus b times negative 2 plus c is equal to y, which is negative 1. Okay? I'm going to rewrite that over here as 4a minus 2b plus c is equal to negative 1. The second point, 1 and 11, let's put that one in. A times 1 squared plus b times 1 plus c is equal to 11. So that comes out to be 1a plus 1b plus c, or 1c, equals 11. And now we can use the third point, 2 and 27, and again we're plugging this into this equation. So a times 2 squared plus b times 2 plus c is equal to 27. So this becomes 4a plus 2b plus c is equal to 27. Now we have a system with 3 variables and 3 equations. Again, the easiest way to solve this, yeah, you can do determinants if you want. Yeah, you can do this by hand. But why do that to yourself when you can use inverse matrices? Okay? So, I'm going to rewrite my equation as a matrix. My coefficient matrix first. So for my coefficient matrix, I'm going to make the matrix of all the numbers in front of a, b, and c. So 4, negative 2, 1, 1, 1, 1, and 4, 2, 1. This is being multiplied by a, b, and c. Those are my variable matrix. And it's going to equal these constants of negative 1, 11, and 27. Hopefully you guys remember this is your a, this is your b. You type these two into your calculator, and then in your calculator you type in, well, I'm just going to say a, b, and c will equal a inverse b times they're being multiplied. So let's get the calculator out. I already have these pre-typed in because, you know, I can do that. But this is what it should look like. You go to second matrix, which is the inverse button, and go over to edit A, make it a 3x3, and enter in all your points for your constants, or not your constants, your coefficients, and it should look like that. Do the same for B. Edit B, and it should be a 3x1 that looks like that, negative 1, 11, and 27. And then finally, to solve this, we go second matrix, we want to name A. We hit the inverse button, second matrix, B. And when you hit enter, you get your A, B, and C value for the problem. Okay? So, the answer was 3, 7, and 1. So that means A is equal to 3, B is equal to 7, and C is equal to 1. So, let us write that out. Our final answer then for standard form is y is equal to A, x squared, plus B, x, plus C. And there is our equation in standard form. This quadratic equation, if you type it in, will go through the points negative 2, negative 1, 111, and 227. Okay, and I cannot stress how important it is to know how to do this. So, what I would say to you right now is try it again. Try what we just did on your own right here on this last problem on the notes and see what you can do. Okay, pause the video and go from there. Alright, well, hopefully you paused. Now I'm going to do this. So we already know it's ax squared plus bx plus c. So a times negative 1 squared plus b times negative 1 plus c equals 5. Now, here's what this one's a special case actually because of this. That's like our y-intercept. So, look what happens when we do this. You actually don't need to use matrices for this one because look what happens. And we'll rewrite these in a second. Okay, so look at this green equation. When you simplify this, you get c is equal to 3. We already have our c value. It's the intercept. So now we can rewrite these equations, putting c in, and we can solve a system by hand if you want to. Now, if you don't want to do that, you can set it up like this, put in the zeros if you want, and just do a 3x3 matrix if you feel more comfortable doing that. And some of you guys might have done that, and that's fine. However, you can do it by hand this way, and it might be faster for you. So now I have the equations a minus b. If this is a 3 here, plus 3 equals 5, which means I have a minus b equals 2. That's one equation I can use. And down here, this is going to be 9a plus 3b plus 3 now equals 9. So my other equation is 9a plus 3b equals 6. Okay? So now we can solve this as a system, a 2x2 system. You can do elimination. I'll multiply the top one by 3. So I get 3a minus 3b equals 6. 12a equals 12. Because these eliminate. A equals 1. And finally, we can go back to the beginning equation up here. 1 minus b equals 2. So 1 minus b equals 2. So you get negative b equals 1, b equals negative 1. And now I'm done. I didn't have to use matrices. I can just rewrite my equation as it is. The standard form of this problem is 1x squared minus 1x plus 3. And that will give me the equation. So if c is given to you because it's an intercept, you can do it by hand and it's actually not that bad. Again, you can do it the method that we did in number 3 with the matrices too. So, okay, very important, very important. I cannot stress enough how important it is to be able to come up with these equations. So, enjoy your weekend, and I will see you guys Monday.